Hello everyone, my name is John Lamb and I am one of the country's subject matter experts in computer science. I work for the National Centre for Computing Education and I am based here in the northeast of England. I'm going to speak today about the role of computer science in combating antibiotic resistance. In this video, we are first going to look at supercomputers and artificial intelligence, before seeing how they've worked together to great effect. You will need a pen and a piece of paper to write things down. So let's begin. Scientists are using supercomputers to address the world's biggest challenges right now. So how is a supercomputer different from a general purpose computer such as a laptop or smartphone? Teachers can pause the video right now to give students the opportunity to come up with some suggestions. Supercomputers can analyze much larger data sets than general purpose computers. The Japanese supercomputer Fugaku is currently the world's most powerful. It was named after Mount Fuji. So let's look at some of the technical specifications for Fugaku. A typical computer you use around the home, such as a laptop or a smartphone, will have one CPU or central processing unit. Fugaku has got 159,000 central processing units to process the data and instructions. You may also have heard of cores. Cores improve the performance of a CPU. Some CPUs that we use have 2 cores, and that's called a dual core, or 4 cores, which is called a quad core. Fugaku has 7.3 million cores. We also measure the performance of a CPU by the clock speed, and this is normally in gigahertz, normally about 3 gigahertz. Supercomputers are measured in flops, which stands for floating point operations per second. Fugaku runs at 415 petaflops, and peta is 1 followed by 15 zeros. The previous holder of the record for the world's fastest supercomputer was IBM Summit, but Fugaku beat it by a massive 267 petaflops. And like all superheroes, it needs superpower. Fugaku uses a massive 30 megawatts of power when it's running. Just to give you something to compare it with, a typical kettle uses 2 kilowatts. Teachers may want to pause the video now to give the students an opportunity to work out how many kettles would have to be boiling to use the same amount of electricity or the same amount of power as Fugaku. The answer is 15,000. Well done if you got it. It costs 130 billion yen, which converts to 761 million pounds to build. A lot of money. And Fugaku has already run simulations on how respiratory droplets spread in partitioned office spaces and on packed trains when carriage windows are open. And this has helped scientists develop treatments for COVID-19. We can watch a video to show that happening.
Researchers in Japan used the supercomputer Fugaku to simulate how the novel coronavirus spreads. They looked at a case in which 4 people are sitting at a dining table and talking without masks on. When someone talks to the person seated in front of them, about 5% of droplets reach the person. When talking to the person sitting diagonally, only 1/4 the amount reach the person. But when looking sideways to talk to the person sitting side by side, more than 25% of droplets reach the person. Researchers also found that fewer droplets spread when the humidity is higher. In an office setting, 6% of cough droplets reached a facing person nearly 2 meters away at 30% humidity. The amount dropped to about 2% at 90% humidity. Researchers recommended the use of humidifiers and other measures to reduce the spread of droplets in the dry winter season.
In the next section, we are going to look at ways that supercomputers can help us. Teachers may want to pause the video right now to give students the opportunity to come up with as many as they can. First of all, in space, supercomputers are able to process vast amounts of data from space telescopes and have already discovered many things happening outside of our galaxy, the Milky Way, such as planets where we think can sustain life. Climate and weather. In February 2020, the British government announced 1.2 billion to develop a new weather and climate supercomputer. Forecasters said the machine would predict storms, select the most suitable locations for flood defenses, and also predict changes to the global climate. It will be more accurate than the current system. It's expected to be operational by September 22. Although not as fast as a supercomputer, the brain is the most complex machine in the known universe. Supercomputers can simulate the behavior of the human brain or parts of it, and that helps us understand more about how it works. In cybersecurity, supercomputers can identify cybersecurity threats from looking at raw internet data traffic. For a general purpose computer, this would be like looking for a needle in a haystack. The Big Bang. Scientists are able to gather evidence from smashing atoms together at the Large Hadron Collider. And when they feed this into a supercomputer, it is able to rewind the universe so we can understand what happened at the very beginning, 13.8 billion years ago. The spread of disease. Not only can computers simulate the spread of disease, they can also help scientists identify chemicals that stop diseases. This helps towards producing vaccines. Supercomputers can help us understand the effects of earthquakes on the Earth's surface, such as trying to predict when a tsunami will appear, as they are related to earthquakes. Seismic waves can also be used to explore the Earth's surface for oil and gas reserves. Supercomputers are able to use seismic data and have successfully found oil and gas. Finally, molecular modeling. Supercomputers have helped scientists come up with new molecules and new materials which we can then put to use in everyday life. One of those materials is called graphene, and supercomputers are currently looking for many applications for this. Well done if you got some of those. For our next section, we're going to look at artificial intelligence. You would normally associate artificial intelligence with science fiction. Although not as advanced, artificial intelligence is all around us today. We quite often call it AI, and scientists now refer to it as machine learning. Can you think of areas where artificial intelligence is currently used? Teachers may want to stop the video at this point to give students the opportunity to respond. Let's see how many you got. The first one is logistics. Logistics refers to the movement of things from place to place. This could be people or it could be goods. Computer programs based on machine learning algorithms help large companies such as Amazon to efficiently move their goods around the world, and this saves them millions of pounds in fuel costs. By doing this, it reduces carbon emissions and helps look after our planet. Self-driving cars are fitted with sensors and AI software. They use the information from the sensors to make decisions based on the conditions that a driver would normally do. Robots are now able to mimic human behaviors, such as walking upstairs. Using AI, they learn from their mistakes. You come across AI in your online experiences, such as shopping and social media. No doubt you will have seen products being advertised saying, "You may like this," where your previous searches, even on other apps, have been taken into account. AI is now able to detect cancerous tumors by looking at scans, something which would normally be done by a doctor. This frees up the doctor to do other important work with patients. Fraud in banks. Artificial intelligence is able to monitor the complex movement of money between different banks and spot fraudsters, something that a single person would not be able to do. Digital assistants such as Siri, Alexa, and Cortana are able to make decisions and respond to your questions. And finally, chatbots. You may have used a chatbot when you have visited a company's website with a problem. Chatbots take into consideration previous customers and learn from their experiences. Quite often, it seems like you are communicating with a real person. How many of those did you get? If you got some of them, well done, and I hope you've learned something new from the others. So how can machine learning and supercomputers work together to combat antibiotic resistance? Scientists at the Massachusetts Institute of Technology in Boston, USA have made a major breakthrough this year. Their supercomputer called Satori was given chemical information of nearly 2,500 drugs, including 300 known antibiotics. All of these had an effect on drug-resistant bacteria. The supercomputer ran a machine learning algorithm called deep learning. It was able to discover a new antibiotic, which is being called halicin. The name came from the classic sci-fi film 2001: A Space Odyssey. Let's watch a video on that.
Antibiotic that kills drug-resistant bacteria discovered through AI. Team at MIT says halicin kills some of the world's most dangerous strains. A powerful antibiotic that kills some of the most dangerous drug-resistant bacteria in the world has been discovered using artificial intelligence. The drug works in a different way to existing antibacterials and is the first of its kind to be found by setting AI loose on vast digital libraries of pharmaceutical compounds. Tests showed that the drug wiped out a range of antibiotic-resistant strains of bacteria, including Acinetobacter baumannii and Enterobacteriaceae, two of the three high-priority pathogens that the World Health Organization ranks as critical for new antibiotics to target. In terms of antibiotic discovery, this is absolutely a first, said Regina Basile, a senior researcher on the project and specialist in machine learning at Massachusetts Institute of Technology, MIT. I think this is one of the more powerful antibiotics that has been discovered to date. added James Collins, a bioengineer on the team at MIT. It has remarkable activity against a broad range of antibiotic-resistant pathogens. Antibiotic resistance arises when bacteria mutate and evolve to sidestep the mechanisms that antimicrobial drugs use to kill them. Without new antibiotics to tackle resistance, 10 million lives around the world could be at risk each year from infections by 2050, the Cameron government's O'Neill report warned. To find new antibiotics, the researchers first trained a deep learning algorithm to identify the sorts of molecules that kill bacteria. To do this, they fed the program information on the atomic and molecular features of nearly 2,500 drugs and natural compounds, and how well or not the substance blocked the growth of the bug E. coli. Once the algorithm had learned what molecular features made for good antibiotics, the scientists set it working on a library of more than 6,000 compounds under investigation for treating various human diseases. Rather than looking for any potential antimicrobials, the algorithm focused on compounds that looked effective but unlike existing antibiotics. This boosted the chances that the drugs would work in radical new ways that bugs had yet to develop resistance to. Jonathan Stokes, the first author of the study, said it took a matter of hours for the algorithm to assess the compounds and come up with some promising antibiotics. One, which the researchers named Halicin after Hal, the astronaut bothering AI in the film 2001, A Space Odyssey, looked particularly potent. Writing in the journal Cell, the researchers describe how they treated numerous drug-resistant infections with Halicin, a compound that was originally developed to treat diabetes, but which fell by the wayside before it reached the clinic. Tests on B. For more on this story, visit the news article link.
For your final challenge, discuss what this discovery could mean for the world. Here is some extension work. Write an article for a science journal in response to the question, can a computer think? Or if you have computer access, you could create a presentation on how artificial intelligence is being used today. One final idea is to design a computer of your own supercomputer on a piece of A4 paper. Make sure that you include CPUs with cores, cache memory, a clock, and RAM. Also give it a cool name. To find out more about the National Centre for Computing Education, get in touch with us at Cardinal Hume Computing Hub. We can provide access to free resources for lessons and support for teachers. Thank you for listening. Goodbye.